Hello guys, welcome to my YouTube channel. In this video, I'll be sharing with you on how to solve problems on linear sequence or arithmetic progression. But just before we continue, I want to encourage you to subscribe to this channel. Like the video, share the link with your friends, and also remember to click on the notification bell. Thank you very much for your support. All right, let's get started. Question number 1. Find the formula for the nth term of each of the following sequences. So to solve this problem, first you must take note of this general rule. The nth term is equals to a, which is the first term, plus the common difference times n minus 1. So all we are going to do now is to take the first term. The first term in this question a is 7. So identify it. A is equals to 7, and the common difference d. The common difference d is second term, which is t2 minus t1. All right, and that is going to be 13 minus 7, which is equals to 6. So the common difference is 6. So now we are going to plug these values into this formula, and Tn will be equals to a is 7, so place the 7 here, plus the common difference is 6 times n minus 1. So all we have to do now, 7 plus 6 times n is 6n. 6 times negative 1 is negative 6. So let's combine like terms. So this will be equals to 7 minus 6 plus 6n. And this would be 1 plus 6n. Therefore, the nth term of this sequence, the nth term Tn, is equals to 1 plus 6n, or 6n plus 1. So this is the final answer to this question. And if you want to check if the formula is okay, then take, for example, the second term would be n would be 2 for the second term. Just plug in the value. T2 is equals to 1 plus 6 times 2, and this will be equals to 1 plus 6 times 2 is 12, and that will be equals to 13. So if you check the question, the second term, what do we have? The second term is 13. The second term is 13. So that is how you check if the question, if the nth term is correct or not. If, for example, we want to check for the third term, which is 19, all you have to do, n is 19. So T3 will be equals to 1 plus 6 times 3, and this will be equals to 1 plus 18, which is equals to 19. So you can see the nth term is correct. Okay, so that is it for this question. The nth term is 1 plus 6n, or 6n plus 1. All right, let's go to the next question. 1b. Now the first term is negative 9. Say a is equals to negative 9. The common difference d is equal second term minus the first term, and this will be equals to negative 5, just put it in parentheses, minus negative 9. Ensure you put that in parentheses. So now this would be negative 5. So if you use this negative sign to multiply this negative over here, that automatically become plus, so plus 9. So negative 5 plus 9 is 4. So the common difference is 4. Now that we have found the first term and the common difference, all we have to do is to write down the general rule, which is the nth term, Tn, is equals to A plus the common difference times n minus 1. So just plug in the value. The first term is negative 9 plus 4 n minus 1. So this will be equals to negative 9 plus 4 times n is 4n, and 4 times negative 1 is negative 4. So now let's combine like terms at this point. This will be equals to negative 9, negative 4 plus 4n. Negative 9, negative 4 is negative 13. So negative 13 plus 4n. Therefore, the general rule Tn is equals to negative 13 plus 4n, or 4n minus 13. All right, so this is the general rule. So if you want to check if this rule is accurate or not, this is the rule, but we are going to check. So to check for the, let's check for the third term. So the third term, T3, is equals to 4 times 3, 4 times 3 minus 13. So 4 times 3, that is 12, and 12 minus 13 is equal to negative 1. So let's check if the third term is negative 1. So negative 1. As you can see over here, this is the third term, is negative 1. So it means that the rule is accurate. Okay, so this is the answer to that question. All right, let's go to the next question. Number 1C. Now, to solve this problem, as you can see, number 1C, we have the sequence to be 1/3, 2/5, 3/7, 4/9. So whenever you have a fraction as your sequence, the first thing you are going to do is to find the nth term of the numerator. So the numerator we have is, the sequence for the numerator is 1, 2, 3, and 4. So we are going to find the nth term of this sequence, and then thereafter we are going to find the nth term of the denominators. All right, so this would be the first term, A is equals to 1, and the common difference D, which is T2 minus T1, is equals to 2 minus 1, and that is equals to 1. Now, the nth term T is equals to A plus the common difference times n minus 1. So the first term, A is equals to 1, plus the common difference is also 1, times n minus 1. So this will be 1 plus 1 times 1, 1 times n is n, and 1 times -1 is -1. So if we combine like terms, this would be 1 minus 1 plus n. So this will be equals to n. So the nth term of the numerator is n. Also, we are going to find the nth term for the denominator. So now let's go back and find the nth term for the denominator. So the sequence is 3, 5, 7, and 9. So the first term, a is equals to 3, and the common difference, d, is equals to the second term minus the first term, which is 5 minus 3, and that is equals to 2. Equals to 2. So now the nth term will be equals to n a plus d, parenthesis n minus 1. So now let's plug the value into that. So this will be equals to 3 plus the common difference is 2 n minus 1. So this will be equals to 3 plus 2 times n is 2n, and 2 times -1 is -2. So this is equals to 3 minus 2 plus 2n equals to 1 plus 2n. So the nth term of the denominator, Tn, is equals to 1 plus 2n, or 2n plus 1. So the nth term of the sequence, cannot be written as, this is the nth term of the numerator, and this is the nth term of the denominator. So the nth term of the numerator is this. So all we have to do now is to write the nth term of the sequence, which is Tn is equals to n over 2n plus 1. So this is the formula for the nth term of this sequence. So if we want to check if this formula is accurate or not, you just pick maybe the third term. The third term is T3 is equals to 3 over 2 times 3 plus 1, and this will be equals to 3 over 2 times 3 is 6 plus 1, and this will be equals to 3 over 7. So the third term is 3 over 7. Now let's check from the given sequence the third term. As you can see, the third term, this is the first term, this is the second term, and this is the third term. You can see 3 over 7. So that is the formula for the nth term of that sequence. I hope this makes some sense. All right, so let's go on to the next question. Question number 2. The 16th term of an AP is 93, given that the common difference is 6. Find the first and the 28 terms. To solve this problem, first, let's identify each of the values. So n is equals to 16, and the 16th term is 93, and the common difference is 6. A, which is the first term, is what we are meant to find, and also the 28 terms. The 28 term. All right, so first we are going to write down the general rule. So T n is equals to A plus the common difference times n minus 1. So Tn, which is the 16th term, is 93. So 93 is equals to A plus common difference D. N is 16, so this will be 16 minus 1. So A plus 6 times 15, and this will be equals to A plus 6 times 15 is 90. So at this point, we can simply subtract 90 from both sides. So 93 minus 90 is equals to A. So 93 minus 90 is 3. Therefore, the first term is equals to 3. Now, from here, we can now find the 28 terms. So 28 terms is equals to 3 plus the common difference, which is 6, and 28 minus 1. So this will be equals to 3 plus 6 times 28 minus 1 is 27. 27. This will be equals to 3 plus 6 times 27 is 162. 162. So 3 plus 162 is 165. 165. So the 28th term, T28, is equals to 165. So the first term is 3, while the 28th term is 165. So this is the answer to this question, and I hope it makes some sense. All right, let's go on to the next question. Question 3. The 14th term of an AP is 96, while the 25th term is 173. Find A, the 19th term, B, the sum of the 13th and the 56th terms, C, the product of the 6th and the 13th term. To solve this problem, first, we have to pick out the details. So n in the first case is 14, and the 14th term is equals to 96. Secondly, n is equals to 15. Oh, 25, not 15, sorry, 25. So the 25th term is equals to 173. So now to find the 19th term, we must have to look for the first term, which is not given, and the common difference, which is not also given. So remember the general rule, Tn is equals to A plus the common difference times n minus 1. So now let's plug these values into this. So the first case is this. So this will become T14 is equals to A plus D14 minus 1. And we can simply equate these. Instead of changing this to 96, instead of changing that to 96, we can simply equate this to 96. Okay, so this will now become A plus 14 minus 1 is 13. So 13d equals to 96. We can call this equation 1. Equation 1. Also, t 25th term is equals to a plus the common difference and 25 minus 1 is equals to 173. 173. So this would be a plus 25 minus 1 is 24. 24d is equals to 173. And we can simply call this equation 2. So now let's bring them together. So this would be a plus 13d is equals to 96, and a plus 24d is equals to 173. This is equation 1 and this is equation 2. So we can now at this point subtract equation 1 from equation 2. So once that happens, this will be out because a minus a is 0, and now 24d minus 13, that's going to give us 11d equals to 173 minus 96 is 77. So divide both sides by 11, and 11 is going to cancel 11 from here. 11 divided by 11 is 1, and 77 divided by 11, 77 divided by 11 is 7. Good. So d, the common difference, is 7. So at this point, we can now substitute this value into either equation 1 or equation 2 in order to find the value of a. So this would be a plus 13 times 7 is equals to 96. So 13 times 7 is 91. So a plus 91 is equals to 96. So we can now subtract 91 from both sides, and a will be equals to 96 minus 91, and 96 minus 91 is equals to 5. So that means the first term a is equals to 95, and the common difference d is 7. So remember, we are meant to find the 19th term. So with this detail, we can now, okay, so we have the common difference to be 7. Common difference is 7, and the first term is 5. So the 19th term, T19, is equals to the first term, which is 5, plus the common difference, which is 7, and 19 minus 1. So this is equals to 5 plus 7 times 18. So 7 times 18 is 126. So this will be equals to 5 plus 126. And 5 plus 126 is 131. So the 19th term is equals to 131. So this is the answer to the first part of this question, the part A of this question. B. Find the sum of the 13th and the 56th terms. So T 13th term is equals to the first term plus the common difference 7, open parenthesis, 13 minus 1. So this will be equals to 5 plus 7 times 12. This will be equals to 5 plus 7 times 12 is 84. So 84, 5 plus 84 is 89. 89. So the 13th term is equals to 89. And the 56th terms is equals to 5 plus 7, open parenthesis, 56 minus 1. And this will be equals to 5 plus 7 times 55. So 7 times 55 is 385. So this will be equals to 5 plus 385. So 5 plus 385 is 390. So 390. So the 56 times is 390. So the sum of the 13th and the 56th terms would be equals to the 13th terms plus the 56th term, which is 89 plus 390. So 390 plus 89, and this will be equals to 479. So this is the answer to the B part of this question, and I hope this makes some sense. All right, let's take the next question, question C. Question C, the product of the 6th and the 13th terms. All right, so the 6th term is equals to 5 plus 7, 6 minus 1, and this will be equals to 5 plus 7 times 5, 5 plus 35, and this will be equals to 40. Recall that the 13th term is 89. So the product of the 6th term, T6 times T13 is equals to 40 times 89. And this will be equals to 89 times 40, 3,560. So this is the answer to this question, and I hope it makes some sense. All right, so this is all we will be able to take for today. Please, if you find this video useful, don't forget to subscribe to this channel, like the video, share the link with your friends, and also remember to click on the notification bell. Thank you very much for your kind support. All right, see you in our next video. Bye bye.